Hi everyone, I'm Harish Palakurti. I'm pursuing my master's in business analytics and data science at Oklahoma State University with FHIR School of Business. And today I'll be talking about my project that I'm going to present at Informs Analytics Conference 2025, which is enhancing FHIR data accessibility with AI agentic chatbots. So we'll dive into that. And the first one is a problem statement. So the FHIR, which is nothing but fast healthcare interoperability resource format, which generally stores all the patient data, all the medical data of the patient, etc., in a JSON file, which is generally good for interoperability and storing the data. So that is deeply nested, hierarchical, and relationally complex because it's a JSON and nested hierarchical. So that's the reason it's not easy for analysis and also extraction. So our solution to that problem is we need to extract the data from the FHIR and store it in relational tables. So extraction, it cannot be done directly by the JSON flattening, but we might need to use custom code to do that part. And also then storing that isn't going to solve the problem for medical researchers or practitioners because they will not be having enough technical knowledge to write a query and to access the data. So for that, we are making a chatbot which interacts with the providers, researchers, etc., with natural language. So we get deeper into the FHIR and what is FHIR at all. So the FHIR is nothing but a standardized framework for healthcare data exchange. So because different practitioners work on the same patient and they will be giving data about the patient and that will be stored as a single document, which is FHIR. Next, why this is important? The data about the patients are present in FHIR, but we cannot directly analyze that FHIR because it is at patient level. We need to convert that to resource level. So what is a resource type here? So the FHIR is consisting of 50 resource types like encounter, observation, procedure, etc. What is meant by an encounter? So whenever a patient meets a provider, that's called an encounter. Whenever a patient takes or undergoes a procedure, that is also an encounter. So what's a procedure? Any operation or anything, any surgery on the patient is called as a procedure. So all those things of a particular patient are stored in FHIR. But now what we're going to do is we are going to extract data from this and store this in a relational table at resource level. Now all the encounters of all the patients are available in one table and so on and so forth. Then we have, so that will be helpful for us, right? Next, going forward, why this chatbot? So we have stored the data at resource level in databases, but for the researchers to work on it, they need to send a natural language query and they need to get the results out of it. So for that, first step would be the document extractor. So all these tables in the database will be having definitions and also each column has a definition and the function of it. So we have taken all those things and put it in different documents and then we have converted those documents into embeddings. Then embeddings are stored in a vector database. Why? Because whenever a user asks a question, that will be used to get more context for that question. For example, so if we see here, the user has entered a query and that will be sent to a meta agent. So meta agent will decide whether the provided question is self-sufficient to get results. If it is not, we need to add more context to that question. So if there is no context or less context in it, that meta agent will send that question to the encoder model, which will convert that question into an embedding, and that embedding will be sent to the vector store for a similarity search. So that question will be similar or semantic searched with the tables in the database. So we will be getting relevant tables out of that similarity search, and those details along the question along with the documents will be sent to the rephraser agent over here. So the rephraser agent will rewrite the question with the more context that it gets from the tables. Then the rephrased question will be sent to the SQL agent. So SQL agent either can get the question directly from meta agent. If the question is clear, the agent will send it to SQL agent. The question is not clear, it will go through this pipeline and come back from the rephraser agent. So once the SQL agent get that question, it will extract all the tables information from this database and see what are the relevant tables for it to write the query. So it will get the tables, then we'll get the table definitions to see what columns are available in that table and formulate the SQL query and get the results. So once the results are available with the SQL agent, it will send that question along with the SQL results to a validation agent, which will check, okay, this is the given question and these are the results. So are they in sync? If not, it will write corrections and comments on that results and send that back to the SQL agent. Then the SQL agent will go through those comments and rewrite the SQL query to get the new results and then send the new results to the validation agent. So once the validation agent is satisfied with the question and the results, then it will send it to the meta agent and then the meta agent will send those results to the user. So this is how the backend works. But for the user, he will be typing in a question, then the question can be rephrased. Whatever happens in the backend doesn't matter, but the user will get the results. So this is the architecture. So again, AI-driven data accessibility is the next step. So why we are doing it? Because researchers and medical professionals struggle to understand the structured query language. So to help them, we are building an efficient system. So for example, you can see what are the most common chronic conditions in patients over 60. So in this, the tables required might be a conditions table, patients table, and there will be a date table to get. Then it will write a query and see who are over 60, filter those. All those things will be done by the agents, and at the end, output will be something like these are the most common conditions in patients over 60 kind of stuff. So it is very helpful for medical researchers. Next will be impact and key benefits of because of this. So till now, there are no standardized solutions for FHIR data accessibility. Even if you do a Google search, there will be very limited options that are available and which are not compliant, or like which are good, I would say, but not the best. So we are trying to give them a more better version than that are available in the market. Not only just extracting the data, but also giving them a chatbot to chat with to get the results directly. So that is one of the major breakthrough that we are having from this. And also the conclusion of Future Scope will be like, we are trying to give them, we will try to give them the results with real-time data ingestion from the FHIR. So till now we are getting data from providers, then we are extracting data, and then it's in the batch pipeline kind of mode, but we want to do it in the real-time FHIR ingestion, and also increasing the agent capabilities as this is an evolving scenario right now. So once we get more and more agents and powerful agents, we will try to embed those into this solution. So I'm Harish Palakarthi, and if you have any queries about this, you can contact me with that email address, or you can connect me on LinkedIn. Thank you so much.